in order to solve system of equation. And then the last part of this topic is of course about this, how to apply this concept in the economic and management, or economic and business. Okay, as usual, I hope you can pay your attention and please mute your mic. But if you have any question, you can ask me at any time. Just turn on your mic and then ask your question clearly. But and then just let me know immediately if during our lecture if my audio or visual are not clear. Okay, I will record this session will be recorded, and then the link, the video recording, the link of the video recording, I will share with you in UKM Folio. Okay, for our class today, we will discuss about the first part of matrix. What is a matrix algebra? I hope we can finish this topic today, because this topic will be included in our mid test, in test examination, in test mid test, peperiksaan pertengahan tahun. Whereas the test has been scheduled for as I think will be we're going to have our class, our mid test on Thursday, 18th December, if not mistaken, 8 p.m. until 10 p.m. Okay, the detail about the test I will share with you later. But for today, I will explain about what is matrix algebra. This topic will be included. It's one of the topics that will be tested in your final exam. Okay, what is a matrix or algebra matrix? Matrix algebra, by definition, matrix algebra refer to the rectangular array of number, satu susunan nombor or element that consisting of m horizontal row, satu baris m baris yang melintang, and also n vertical column. M row or baris and n column or laju. In matrix, there are number of column and a few number of laju. So let's say we have this example of matrix. Normally, when we draw a matrix, we can write like this: matrix A equal to there is a open and close bracket. The element or the number of the matrix normally will be we write the element of the matrix in a bracket. Okay, matrix A is called M times N. There is the size of the matrix, the order of the matrix, the size of matrix A, the order of matrix A, M times N matrix. M times N matrix. That is the order of matrix A, or the size of matrix A. In other words, M is a row, number of row times number of column, number of column. There is the basic definition of matrix. Okay, for example, let's say I have this matrix A. Okay, this matrix A. In this matrix, the first row of the element of the first row is 3, 1, 6. That is the element of the first row. When we read horizontal, when we read by horizontal, 316 is the number, the row number 1, and then the next one is row number 2. The row number 2, there are number of 2, 4, and -1. 2, 4, and -1. In other words, that is the element of matrix A. But this matrix can also be read as a column. The first column, first column, second column, and third column, column number 3, column. So the first there is 2 number in column 1, 3 and 2. In column 2, there is 2 elements, 1 and 4. And column 3, there is another 2 elements, 6 and -1. Okay, the element of the matrix can take any number from the negative infinity to the positive infinity. So for matrix A, we can describe how to describe matrix A. Matrix A has 3 rows and 2 two row and 3 column. So in other words, the matrix has the size of 2 times 3, or the order of the matrix is 2 times 3, 2 row and 3 column. That is the size of matrix. So A11 is the first element of first row, 3. The first element of first row. The second element of first row is 1, A12. There is a number of row. The first number if you write like this, okay, Aij, A11, sorry, A11. Let's see what is A11, and then we have A12. The first number it refer to row, the second number refer to the column. That's the element in the matrix. We can describe the element in terms of A11, A12, A13, and A21. A21 is the refer to row number 2. The second row of the first column, second row, second column, second row, third column. That is the element of a matrix. That the basic concept of the matrix. For this case, for example, we have, let's say we have another matrix here. This matrix has 1, 2, 3 row and 1, 2, 3, 4 column. So this matrix we call it this matrix. In other words, we can say this matrix A has the size of normally the size will be right like this. This matrix has 3 row times 4 column. Matrix 3 times 4. That's about the matrix. In matrix, we normally we will talking about the how many row and how many column. Okay, that's the general part of the matrix. Okay, the other part I will leave it. I will leave the other part type of matrix. I hope you can study for yourself. There is just a concept. I think for sure there's no problem for you to understand by just reading this concept. But I would like to proceed to the how to do the what we call it as a matrix operation. Please read the what is the type of matrix, transpose matrix, and so on until equality of matrix. I hope you will read this part, that part. But for today, I would like to focus on the how to perform the matrix operation. Okay, as a matrix is also in one matrix there is a number, there is an element in the matrix or number in the matrix. The element of the matrix, the element can take any number from negative infinity to the positive infinity. Nilai-nilai dalam matrix boleh mengambil sebarang nombor daripada negative infinity sampai positive infinity. So in other words, we can say that there is of course since there is a number in a matrix, so of course we can do the matrix operation. The matrix operation such as addition, penambahan, subtraction, pengurangan, kali, multiplication. Of course we can do we can perform the operation in the matrix in matrix. But there is some condition we need to fulfill. Not all whether the additional or subtraction or multiplication can be performed, can be calculated for the matrix. That depends on the few conditions. For the first one, when we're talking about what is a matrix addition and subtraction, penambahan dan penolakan matrix. Bagaimanakah untuk melakukan penambahan dan penolakan matrix? Okay, there is two matrix. Any matrix may be added or subtracted if and only if they have the same size. That's the first condition. Syarat penting dia ialah semua matrik yang terlibat dalam penambahan dan penolakan mesti mempunyai size yang sama. Number of row for matrix A, it must equal to the number of row of another matrix. Let's say matrix B. Number of column equal to, for matrix A, equal to number of column for matrix B. If you want to add or to subtract two matrices, make sure both of them have the same row and same number of row and column. Okay, for example, let's say we have this matrix. Matrix A 2 times 3, matrix B 2 times 3. So in other words, we can perform the subtraction. We can perform the mathematical operation such as addition and subtraction. Okay, let's say I will choose this two matrix. For example, let's say I would like to yeah, I like to copy this. Say for example. So just want to copy this matrix. Please refer to the note. Okay, let's see. Uh-oh. Okay, okay. Where is the matrix? Okay, this one. Good. Okay, please refer to page 2. Page what page? What page? Let's say page 6. Page. Let's say we have these two matrices. Okay, so matrix A has two rows. Number O, there's 1 and 2. The matrix B, it also has two rows, 1 and 2. The number of column is matrix A is 3, 1, 2, 3. The number of column is matrix 2 is B is also 1, 2, 3. Matrix A has 2 rows and 3 columns. So A is the size of A is 2 times 3. Whereas matrix B, the size of matrix B is also 2 times 3. So since the size of A and B is equal, we can do this matrix operation. A plus B, and for the subtraction is actually A minus B, or B plus A and also B minus A. All this operation can be done by using the matrix addition or subtraction, subject to the question. Okay, but since both of them have A and B have the same size, we can calculate A plus B, B plus A minus B, or B minus A. Okay, let's say for example, let's say how to calculate. Let's say the first one, A plus B. Let's see what is A. Okay, matrix A. The 2, 3, 5, 4, 1, 2. That is matrix A. Whereas matrix B, this equal to 1, 2, 6, 1, 2, 6, 3, 2, 1. That is matrix. So we need to calculate what is A plus B. Okay, since matrix A has the A and B has the same row, same number of row and column, we can calculate the A plus B. But the next question is how to calculate A plus B. For example, how to calculate? Okay. First, okay, the easy the easy way to do this operation is you need to understand, if we do the matrix operation, they must be done one by one. The first row of the first element of matrix A must be add to the first row of B. Second row, the first element of A plus to the first element of B. Second element of A plus to the second element of B, and so on. We must do one by one. So we need to find, okay, what is the first element of A is 2. The first element of B is 1. So the answer is 2 plus 1. There's 2 plus 1. The second element of A is 3 plus the second element of B, 2, 3 plus 2, and so on. So the next one is 5 plus 6. Okay, that's the operation for the first row. And then we continue the same concept for the second row. The first element of the second row, 4, of A, plus to the first element of the second row, B, there is 3. Now the operation is 4 plus 3, and then the next one is of course 1 plus 2 and 2 plus 1. Okay, that is the matrix A plus B. So we can complete this operation. A plus B equal to 3, 5, 11, 7, 3, and 3. Okay, that is the matrix A plus B. If you have any question, you can ask me now. I hope you can follow the basic concept of the basic concept of the matrix. Okay. Let's say the next operation. Let's say I would like to do A minus B. A minus B. Let's say A minus B. The next operation is A minus, okay, not A minus B, B minus A. Let's say I just want to show the variety of the matrix B minus A. So what is B plus A? What is B minus A? So the first matrix now is a B. What is the matrix B? Matrix B is 1, 2, 6, 3, 2, 1. Matrix B is 1. Let's say matrix B. Okay. B minus A. This equal, what is a B? The first matrix now is B. So B is 1, 2, 6, 3, 2, 1. That is B. Minus matrix A. What is matrix A? Matrix A again, 2, 3, 5, 4, 1, 2. 2, 3, 5, 4, 1, 2. Okay, that's B minus A. The first matrix is B, the second matrix is A. So again, like the same, the process is equal to is similar to the matrix addition, but for the matrix subtraction, we need to subtract by we need to subtract the every element, the first element of B. In other words, the first element of B subtract minus the first element of A. The second, there is 1 plus 1 plus 2. The second one is the second element, I mean in the first row, the second element of B minus the second element of A, there is 2 plus 2 plus 3, and then the last one is 6 plus 6 minus 5. 6 minus 5. Now we move to the next row. The second row is the first element of second row is 3 in B minus the first element of second row of A, there is 4. So there is a 3 minus 4. Let's see, 3 minus 4, and then the second element is 2 minus 1, and the last element is 1 plus 2. There is a matrix B minus O. So the answer is the matrix B minus A is negative 1, negative 1, 1, negative 1, 1, and negative 1. Okay, that's the answer. How to write the answer? That's matrix B minus A. B minus A. That's the matrix operation in terms of additional and subtraction. Operasi matrik dalam konteks penambahan dan penolakan. Okay. So let's say now okay, the next one again. If you have any question, you can ask me anytime. Okay. Now let's say I create another one matrix. Let's say I have this matrix. Let's say matrix C. Let's say matrix C. The element, the component of C, the element of C, let's say 2, 4, 6, 1, 3, 5, 5, 10, 11. That's it. So for the matrix C has 3 rows and 3 columns. 1, 1, 2, 3, 1, 2, 3. The matrix C, the size of matrix C, the order of the matrix C has order of 3 times 3. The number of column in matrix C does not equal to the number of row of matrix C does not equal to the number of row of matrix A and B. So in other words, matrix C cannot be we cannot find the addition, or we cannot calculate the matrix addition or matrix subtraction for A. Let's say I would like to find A plus C. The answer is cannot be calculated. Cannot be calculated. Since A and C has different size. As the size of A does not equal to the size of matrix C. Same if we want to find A minus C, C plus A, C minus A cannot be calculated. Same goes to A, C, and B, because C, B also has the different number of row with since A and B and C has a different size of matrix. So in other words, what I'm trying to say is, in matrix, if you the two matrix can be added or subtract if the two matrix, both of them have the same size. The same size refer to the situation where the number of row in the matrix, the number of row and column in matrix A equal to the number of row and column in matrix B. Okay, that's in other words, the size of matrix A and matrix B must be the same before we can find the addition, or before we can calculate the matrix addition or matrix subtraction. Okay, that's the first condition for the plus minus, untuk kita menolak dan mencampurkan matrik lihat pada bilangan baris dan laju bagi matriks tersebut. Okay. Okay, let's see. Okay, the next one, please refer to page 3. What we call it as a matrix scalar multiplication. You can see it as a scalar multiplication. Yes. Scalar multiplication, which one? Okay. Okay, we'll call it as a scalar multiplication. Multiplication. By scalar multiplication, we add the matrix, we multiply a matrix by a scalar, by a number. Let's say, for example, I have this matrix. Let's say this matrix A equal to 3, 8, 1, and 7, 1, 3. Let's say I have this matrix A. So I would like to find 3A. What is 3A? 3A, in other words, we need to multiply all the elements in matrix A with 3. Okay, in other words, the matrix A is increased by 3 times. So the first one is 3 times 3, 8 times 3, 1 times 3, 7 times 3, 1 times 3, and 3 times 3. That's a new matrix, that matrix 3A. So the answer is 9, 24, 3, 21, 3, and 9. That is the matrix 3A. That's we call it as a scalar multiplication. We multiply each element in the matrix by the scalar, by K. We can also, the scalar is K. Okay, the next one, okay, the matrix addition, matrix subtraction. Okay, the next one is a matrix multiplication, pendaraban matrix. Okay, pendaraban matrix, which one? Okay, this is important. It's very important. It's very crucial in this topic. Normally, we apply this concept more in application. This concept is very important, for example, especially in application of matrix in economic and business. Okay, what is how to perform the how to do the matrix multiplication? How to calculate this matrix multiplication? Okay, the matrix product or the matrix multiplication of A and B is defined and only if it's defined can be, in other words, can be calculated. We can find the matrix product of A and B if the number of column of A. Now, again, we are talking about A times B. In other words, A times B. That's equal to AB. The first matrix is A times the second matrix B. So we call it, we say A times B. The product of A times B or the product of AB can be defined if and only if the number of column of A. Okay, please remember this. The number of column of A. The number of column of first matrix, the number of column of the matrix 1, that is A, equal to the number of row of second matrix, the number of row of matrix B. The product of B as many row as A and as many column as B. The order in which the matrix is in a product is written is extremely important. The order of which the matrix in a product are written is extremely important. In other words, when we find if we want to find the the product of A and B, first we must we need to identify the number to check whether the column of A equal to the row of the second matrix, and then the order of the output, the matrix, the product of the matrix, the row of the matrix AB is equal to the row of the first matrix. The number of column of the matrix B is equal to the number of column of the number of column of the product matrix AB equal to the number of column of matrix B. Okay, that's the that's how to find the matrix multiplication. Okay, so okay, there is one example here. Okay, I will explain to the example. Okay, in page on page 8. Okay, there is the complete step by step. This page show you the complete way, the complete step by step, the complete step of the calculation, how to find the matrix multiplication. But again, in this class, I will show you how to find that calculation one by one. For this topic, you need to understand this concept. So this concept very important that we will apply this concept in business and economy later, especially when we want to find the what we call it the intersection point, the equilibrium point in economic and business. Okay, before that, before I proceed, let's say we take this example. Okay, we take we look to we choose the example. Let's say I have these two matrices, A and B. Let's say okay, I have this matrix. Let's see this matrix, we have this A and B, matrix A and matrix B. Now we would like to find the AB. What is the matrix A times B? Matrix A times B, for example. Matrix A times B. So before we proceed, we need to identify whether the matrix has whether the matrix can be multiplied or not. First, in order to find the matrix, in order to find the product of A and B, first we need to know the size of A. The size of A is 2 times 3, and the size of the second matrix, in other words, the size of matrix B. is also 2 times. Sorry, the size of matrix B, or matrix B, as you can see here, the matrix B has the three row and 3 column. 3 row and 3 columns. So the size of B is 3 times 3. The size of A is not equal to the, it's not need to be, the size of A is not equal to the B. In this concept, in order to find the multiplication is not necessary for the matrix has the same size. But for additional and subtraction, that's why that's the main condition. You must fulfill the matrix must be has the same size. But for the multiplication, we just want it's not necessary the matrix has the same size, but we need to identify whether what is the first matrix and which matrix is the second matrix. In this case, clearly that this the first matrix is matrix A, the second matrix is matrix B. The matrix A has the size of 2 times 3. The matrix B has the size of 3 times 3 times 3. Okay. So before we can proceed, we need to check, okay, what is the rule, the condition here. Okay, the number of column of first matrix, the number of column of matrix A is 3, must equal to the number of row of matrix B. In this case, the number of row of matrix A equal to the number of row of matrix B. In this case, we can find the multiplication of A and B. The product of A and B can be defined, can be calculated, because the number of row of first matrix B is equal to the number of row of the number of row of the second matrix. So in other words, let's say I have this matrix C and D. Matrix D is 2 times 1. D is 3 times 1. The number of matrix, the number of row of C is not equal to number of column of C is not equal to number of column or number of row of D. So this operation cannot be the product of C and B cannot be calculated. Okay. So in this case, okay, let's see, I just want to show you, and okay, C times B cannot be calculated. Same if I have this matrix number. Let's say matrix E, I have 3 times 3, but matrix F is 2 times 3. The number of row of the first matrix that is not equal to the number of the number of column of first matrix is not equal to number of row of the second matrix. So again, this we cannot find this. We cannot find that the product of EMF is cannot be defined or cannot be calculated. So what I'm trying to say here is, in matrix multiplication, it is very important to identify whether the number of row of first matrix equal. It must determine whether the number of rows of matrix equal to the number of column of second matrix. That's how to find the product of A and B. Okay, for example, in this case, the number of column of A equal to the number of column of B. So the number of column of A equal to the number of row of B. Okay, sometimes I also confuse here. Okay, be careful again. In this case, the number of row of A equal to the number of row of B. So we can find the product of A and B. In other words, we can define that the product of matrix A times matrix B. Okay. If okay, now what the next question is, what is the size for the product? What is the size of the product? A times B, let's say we have C equal C. What is the size of C? What is the size of C? Okay, what is the size of C? The size of C, the matrix C we have the number of row in matrix C will equal to 2, will equal to the number of row of first matrix. The number of column of the second C must equal to the number of column of the second matrix. In other words, in this case, if A times B, the size of A is 2 times B, the size of B is 3 times C. The product of the matrix C, the size of C, the size of the product of the matrix, the size of C is C will have the number of row of A times the number of column of B, 2 times C. So in other words, the product of A and B equal to C, where C has the size of 2 times C. The order of matrix C is 2 times C. Whereas why? Because the size of A is 2 times 3, the size of B is 3 times 3. That's the how to this point is very important in order to help you to find to find the correct answer. Okay, there is a clue here. If we the product of A and B must equal to the size of the product of A B is 2 times 3. I mean the size of the matrix C. Okay. Again, if you have any question, just let me know before I proceed to do the operation. Okay. Any questions so far?
No question, doctor.
Okay, let's see how to find the product of AB. Okay, product of AB. I hope you can pay your attention here. The product of AB. Okay, let's see what is A. A is the matrix of A is equal to, let's see, I would like to see. Okay, let's see this okay, I would like to apply the concept again in this case. Let's say we have a matrix A and matrix A and matrix B. Okay. So we know A, B, we can find the product of AB. The product of AB equals C, where C has the size of 2 times 2. 2 times 3. Okay. So what is the matrix C? Okay, what is matrix 2 times 3? We are going to have 2 rows. Let's say 1, 1, 1, 2, and 3 column. 1, 3. 1, 2, 1, 1, 2, 2, and and A is a number, any number. It could be positive or negative. A, 3, 3. That's the description, the nature of matrix C. Matrix 2 times C. There are 2 rows here and 3 components. Three column. In total, they have 9. They have 2 times 3. 6 element in the 6A. 6 number. 6 number in 3 column and 2 column. Two row and 3 column in matrix C. So now we need to find what is A11, A12, A13, A21, A22, and A33. Okay. So, okay, how to find this matrix? Okay. Matrix C, and so we need to find the each element. Okay, for the first element, okay, there is A11. Okay, I will show you how to find A11, A12, and A13. A11, in other words, A11. A11, the first number is referred to the row. The second number is referred to the column. The first number, let's say the first number, A11, this first number is referred to the first column of matrix A, the first column of the second matrix. And the second one, the second number one, A11, the second number one is referred to the column. So in other words, in this case, we need to uh, uh, find the summation of the product of element in first row of A and first column of matrix B. how to yeah, what is all about how to find this how to do the to calculate this to find this A11. Okay, now we need to in other words, we need to find the summation of product between the element in first row of A and first column of P. Okay, in other words, I refer to this the first row of the first row of uh the first row of the first row of A, this one, and the first column of P. That is A11. The first column of A and the first column of P. What we need to do is we need to find the summation of the summation of the product of the element. So, for example, we need to find the product of this number 2 times 1. 2 times 1 plus the second element of A and the second element in A, number 1, and the second element in the first column of B, 0. 1 times 0 plus then the third element in the first row of A times the third element of B in the first column. That is negative 6 times negative 2. Okay, we can calculate this number. There is A11 that is equal to blah 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 is 40. It's 40. Okay, how to perform the number. Okay, A12. Okay, A12. Okay, that is the summation of product for the element in the first column of A and the second column of B. Now we move to the second column of B. Okay, this is the second column of B. There is a 0, 4, and 1. There is number 0, number 4, and number 1 in the second column of B. Okay, seen? So the process is the same. We just find the summation of the product. The first one is 2 times 2 times, okay, let's see the number. Okay, 2 times 0. That is 2 times 0 plus 1 times 4 plus negative 6 times positive 1. Negative 6 plus 4, it is equal to negative 2. That's for the second element of C, second element of matrix C. In the second element of the first row of the matrix C. Okay, the next one is the multiplication, the summation of product between the first row of A between the third row of B. What is the third row of B? Okay, this one. The third row, sorry, the third column of B. Negative 3, 2, and 1. That's the connection, how to find. So again, we need to find the summation of product. The product first, we need to find find the quantification, and then we do the summation. So there is a positive 2 times negative 3 plus 1 times 2 plus that's negative 6 times negative 1. The answer is that's negative 6 plus 2, positive 8, negative 6 plus 2. I hope this 1, 2 times negative 6, there is a negative 10. Okay, that is for the first row, A11, A12, and A13. Okay, this element, A11, A12 and A13. So the next one is the second, the element of the second row, A21, A22, and A23. Okay, now we can apply the same concept here. A21. Let's say A21. A21 is for the first number is the second is for A. The second number is for B. A21 refer to the second row of A. Second row of A. This one, second row of A, and then times the first row of B. Okay, first row of B. Okay, what is the first row of B? Okay, this is the first row of B. Okay, need this one, this number, -1, -2, 0, and -2. So this equal to A21. This equal to 1 times 1. This number 1 times 1 plus -3 times 0. -3 times 0 plus +2 times -2. 2 times -2. 1 plus 0 plus -4. 1 plus -4 equal -3. That is for the first element of the second row, A21. The element in the second row of A times the element of the in the first column of B. That's the how to find the matrix multiplication, especially for matrix 2 times 3. Okay, again 2 times 2. 2 times 2. Now we refer to the second column of A and second column of A and second column of B. This one. So this is the first one is 1 times 0. 1 times 0 plus -3 times 4 plus 2 times 1. 0, -11 plus -12 plus 2, -10. I think the answer is -10. Please refer to page 8 in my notes in matrix algebra notes. Okay, A22. Okay, the last one is A23. The second element of the second row and the third column. Okay, this. So the second row of A. Okay, this number, and the third column of let's say the third column of B. That's why the matrix is the matrix 2 times 3, 2, 3, the second column of A times the third column of B. That's the condition of the situation, how to find this multiplication. I think, yeah, that is quite long here, but you must do it carefully in order to find the right number. Okay, for A times 3, the number in the first row of the first number in the second row, this one, 1 times the first number in the third column of B. That is -3. That is -1 times -3. -1 times -3. Second one is the second number in the second row of A times the second number in the third column of B. That is -3 times 2. And then the last one equal to the multiplication of the last number of A, the element of A in the second row and column number 3, that is 2 times to the last number of B, the last element of B, that is 1. So this one and plus negative positive 2 plus 1. And there's a negative 3, a positive 3, positive 3 minus 6 minus 3 plus 2 equal to, I think 1 times 3, C, 1 times 3, 3 times 2, and plus 2, positive 2. Okay, that's correct. 3 times 3 minus 6 minus 3 minus 3, okay, 3 times 2. Okay, I hope that this, the answer is, okay, this is a negative 1. Okay, that's why this is not negative 1, this is a positive 1. Okay, positive 1, negative 3 plus negative 6 plus negative 3 plus negative 6 plus negative 2, that is equal to negative 7. Okay, that's the answer. Now we can identify the number for A11, A13, A12, A13, A21, A22, and A23. So now we just take this the first row of matrix C. Okay, the first row of matrix C equal to A11, A12, and A13. The first number is referred to the number of row. Row number 1, there is 40, 14, negative 2, negative 10. For the second row, this equal to negative 3, negative 10, negative 7. That's the matrix multiplication. And this quite you need to do it very carefully in order to make sure you get the right answer. Okay, the calculation is easy, but you need to find, for let's say uh, uh let's say uh let's say in this case we have 2 row and 3 column for A and for A and B, and then in other words we have 6 element here in matrix C. Okay, that this is the correct answer. Okay, if you refer back to the muka surat 10, there are a few examples here. I hope you can find this. You can do your revision. Please do it manually. Calculate again, and then how to find the matrix. Okay. Okay, for your homework. Okay, for your homework. Okay, in this class, okay, there is A times B. Okay, there is A times B. A times B. Okay, for your homework. Okay, let's say homework is find or calculate B times A. What is B? B is matrix 3 times 3. A is matrix 3 times 2. The number of row for the first matrix is 3. The number of we have 3 times 3 and 2 times 3 matrix A. Matrix A is 2 times 3. Okay, try to find the matrix B times A. Okay, please check whether first you want in order to find the to find the matrix multiplication. First, you need to identify the number of column for the first matrix must equal to the number of row of the second matrix. That is for your homework. Okay, if you want me to check your calculation, you can send to WhatsApp me as usual. I will check for you later. Okay, that's I think the basic concept of matrix. You must understand, you must know this basic concept, because after this we are going to apply this matrix concept in the economic and business. Okay, after the especially in the example in the part B, of matrix. Okay, the other part, I hope I will leave it the other part in the matrix, starting from the method let's say that for this example, and then from the properties of matrix multiplication, there is please do your revision here. Just I think it's quite easy for you to understand. I will leave it to you, please. But this include in our test. Make sure you know what is the property of matrix. Do read what is a determinant, determinant, and then the how to calculate the determinant, and the method of cofactor, and blah 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 to find the determinant. But there's the property of determinant. But after this, I will proceed to the application, how to apply this, how to apply this method. Please refer to the second part of this our note. This is a part A. You can find the part B. Okay, there is a few concepts here. I leave it to you. Please read by yourself and try to understand what is the uh, what is the topic is all about. Because okay, I think after this I will show you how to I will take a few example. The example is not in this note. I will share it with you how to uh, find the solution of the system of matrix, how to find the market equilibrium and so on by using the the concept of matrix. Okay, any question so far?
No questions, doctor.
Okay, if there is no question, I think we take a break for 50 minutes. After this, after break, I will show you how to find how to solve the system of equation by using the method of by using the matrix algebra. Okay, we take a break for 50 minutes. We will continue on for now for 4:30. Is it okay?
Okay, doctor.
Okay, we take a break for 20 minutes.